All right, let's look at problem number 19. This is the integral from 1 to infinity, which means it's an improper integral, of 14 over x times x plus 1 dx. Your numbers could be a little bit different, but the process will be the same. What we're going to do here is, it's an improper integral, so the first thing I'm actually going to do is rewrite this as the limit as b approaches infinity of 1 to b. You know what I might even do is bring that 14 out. It's up to you. You can leave the 14 in there. You can bring it out. It's really whatever your preference is on that case. All right. So what I'm going to do now is I am going to use partial fractions. This looks like a partial fraction problem to me, so I am going to separate this, ignore my limit for just a minute, and I'm going to focus on just this piece. So I have 14 over x times x plus 1 equals a over x plus b over x plus 1. Multiplying everything through by x times x plus 1, we get 14 equals a times x plus 1 plus b times x. And then what I'm going to do is I'm going to let x equal 0, and I get 14 equals a times 1, so a equals 14. And then I'm going to let x equal negative 1. And if I do that, I get 14 equals b times negative 1. And so b equals negative 14. All right, so now I'm going to go rewrite this limit problem. This becomes the limit as b approaches infinity of the integral from 1 to b of a is 14 over x, and b is negative 14 over x plus 1 dx. Okay, so now I'm going to evaluate this integral. And again, that 14 might have been easier to pull out, but we didn't, so we're just going to leave it. And so what I have now is the limit as b approaches infinity of, this one will be 14 times the natural log of the absolute value of x. And this one will be negative 14 times the natural log of the absolute value of x plus 1. And all of this will be evaluated from 1 to b. So let's go do that. It's not going to be pretty, but we can do it. Really, I could set up a division. Might be easier. Let me think through this. Yeah, using my properties of logs, it might be easier. Nah, let's just write it all out. Okay, let's say we didn't see the properties of logs. We would be doing the limit as b approaches infinity of 14 times the natural log of the absolute value of b minus 14 times the natural log of the absolute value of b plus 1 minus 14 times the natural log of 1 minus 14 times the natural log of 2. That's fun. Okay, a couple things before I begin. The natural log of 1, we know the natural log of 1 is 0. So I have 14 times 0, which is just 0. So let's simplify this just a little bit more. I have the limit as b approaches infinity of 14 times the natural log of b minus 14, times the natural log of b plus 1 minus a negative, so that'll be plus 14 times the natural log of 2. I don't really need the absolute value at that point. Well, now I'm taking the limit as b approaches infinity of this. The problem with this is going to be, because of the way it's written, infinity. Hold on, let's think through this for just a second. You know what? I actually am going to go back to my log properties because as it's written, I would have infinity minus infinity, which we know is an indeterminate form. So to avoid that indeterminate form, what I'm actually going to do is I'm going to use my division properties. So this would be 14 times the natural log of b over b plus 1 plus 14 times the natural log of 2. I'm going to ignore the absolute value at this point for the 2. Yeah, I like this better. And the reason I like this better is because this actually goes towards 0. The reason this goes towards 0, if we take the limit as b approaches infinity here, if we take the limit as b approaches infinity, I have infinity over infinity. I can deal with that to get the natural log of 1 over 1 using L'Hopital's on just that piece of it. And then that would give me 14 times 0. So this actually just goes to 0. The other way we could look at this is we're taking the natural log of two things that are growing at the relatively same rate, and the ratio that it's growing at is 1, because b over b plus 1, the ratio would be 1, and the natural log of 1 is 0. So that whole expression goes to 0. And so really what I'm taking is the limit as b approaches infinity of just this 14 natural log of 2. And because of that, did I lose a negative sign somewhere? I kind of feel like I might have lost a negative sign. That is my end. That's my answer to this problem. So 14 natural log of 2 would be my answer, and we are done.